Hi, everyone. My students are asking me so many questions. Okay, let me answer them through this clip. And if any one of them is able to come across this video, that is their cup of tea. So, what is the question? What are the questions that they ask me? I'll let you know. There are 5 in numbers. So, the first one is this: Why? Why? Why do I hear thunder seconds after seeing lightning when rain is about to fall or when it is raining? The perfect answer to the question is this: lightning is made up of what? Light wave. And thunder is made up of what? Sound wave. The speed difference between the two of them, between the sound wave and the light wave, is very high. The speed of the light is 3 times 10 raised to power 8 meters per second, while the speed of sound is 340 meters per second. So, if these two natural occurrences occurs at the same time in the cloud, they will occur at the same time in the cloud. The thunder will strike and the lightning will also emerge at the same time from the cloud. Yet, you're going to see the lightning first before you hear the thunder, because the lightning move faster at that 3 times 10 raised to 8 meters per second speed to you before sound will now arrive later. So that is it, the difference in the speed. So the next question my student asked me is this: Why is it that their phone usually have full signal even though their phone is not connected with wire to any server? I'm saying, wow. The reason is this: it's very simple. This signal you are talking about is made up of electromagnetic wave. An electromagnetic wave does not require a material medium for its propagation. It does not need air, it does not need atom to carry it from its source to where it is needed. It creates its own road and move along it by itself. So that is the reason why, in as much as you are within the coverage area, your phone will have signal and it will move from the mass that is transmitted to where it is transmitted to your phone. So that's answer that question. Now the next question is this: Why is it that the sound cannot transfer or be transmitted along a vacuum, or cannot be transmitted in space? So let's say 2 people are in space, 2 astronauts are in space, one at one point and the other at the other point, and they are shouting at one another. They will not hear their voices. Why? Because the sound requires a material medium. But light, on the other hand, will be seen. So that is why astronauts will be making use of light whenever they are in space to be communicating with one another. Just flash the lights on your other astronauts. It's going to see the reflection of the light and be able to see you. Then they will use the hand to make gesture so that they will be able to communicate properly. So cannot be transmitted in space, but light can, because sound requires a material medium and light does not require a material medium. So another question they ask is this: Why? I repeat, why is that they have to tune their radio to a particular frequency before they can receive service from a particular radio station? Then I'll tell them, you can do that because before you can. In fact, the theory that back this whole process up is called resonance. It's called what? Resonance. which we will talk about later. But let's make it clear. Before energy can be transferred from their own headquarters, the radio broadcasting frequency must be equal to their internal radio frequency. So if you have a radio, the internal radio frequency of your radio must be equal to the broadcasting frequency. Once the two are equal, now there will be easy transfer of energy, of news, of music, of any kind of activities. As much as they are playing it from their own side, you will receive it from your own side, since the frequency are equal. So the last one they ask is why? Why and how are the scientists able to calculate the speed of wave? Since this wave are not visible to our naked eye, how are they able to calculate the speed of wave? How are they able to calculate the speed of light wave? That's why I now say all these are theoretical. They were able to calculate the speed of light wave by making use of a wave equation, which is V equals to lambda F, where V stands for the velocity of the wave, lambda stands for wavelength of the wave, and F stands for the frequency of the wave. So one thing you should know is this: the velocity of the wave is directly proportional to the frequency of. So that is the strategy that the scientists are able to calculate. And they realize that the frequency of the light wave is very high. Definitely, the speed has to be very high. Meanwhile, the frequency of the sound wave is not as high as the frequency of the light wave. That is why the speed of light wave is smaller. So I hope you are able to get that. There is no magic in as much as physics is concerned. No magic. So now let's now go deep and make you to understand what wave is. Wave is a disturbance. Wave is what? It's a disturbance that transfer energy and momentum from one point to another. It has transferring what? Matter. That's it. Then we have types of wave. The first, based on motion, we have the longitudinal wave. Longitudinal waves are waves that vibrate parallel to their motion, while transverse waves are waves that vibrate perpendicularly to their motion. Example of longitudinal waves are sound wave and spring wave. Yes, spring wave. So the next one is examples of transverse wave, light wave, radio wave, and so on and so forth. So based on medium, there are of two types too. You have the mechanical waves and the electromagnetic waves. The mechanical wave are the wave that requires material medium for their propagation. Example of mechanical waves are sound wave and water wave. Yes, water wave needs water before it can move. Electromagnetic waves. Electromagnetic waves are waves that do not require material medium for their propagation. An example of electromagnetic wave: radio wave, gamma rays, infrared rays, all these rays that you see, including light waves, they are all electromagnetic waves. So that is the kind of introduction, the basic introduction I will give to you on the wave. We are now going to the main part, which is solving of difficult questions, the questions that usually disturbs, that usually bother students, that usually give student problems. Calculation questions. That is basically for wave. That's what we are going to be tackling right now. So I'm going to be listing them, I'm tackling them one Bye. Thank you.